Dear participants, within a couple of minutes, we will start the today's session.
Good evening, ma'am.
गुड इवनिंग।
कैसे हैं मैम आप?
बढ़िया है। आप लोग कैसे हो?
बढ़िया हूँ मैम।
पता नहीं, इट
आप
इज नॉट, आई डोंट नो
आपकी
व्हाट्स
आवाज बहुत
हैपनिंग।
कम आ रही है मैम।
ओके, कैन यू हियर मी ऑल ऑफ यू? कैन एनीवन लाइक
Yes,
इज
ma'am,
माय
but
वॉइस?
yes, no, but it's very low, ma'am.
आई डोंट नो, आई यूज द सेम device
No,
every time,
yeah.
but nobody tells that the voice is low.
No, no, now it's okay, ma'am. Now it's okay,
Okay,
ma'am. Yeah.
all right.
Thank you, ma'am.
So, but I'm unable to turn on my camera. I don't know what's happening.
Ma'am, let me check, ma'am.
What's happening? Why it's not allowing me to turn on the camera? Hmm. Mm, I don't know what's happening. Anyway, can you hear me all? Hello?
Yes, ma'am.
Can you hear me?
Yes, ma'am. Yes, ma'am.
I don't know what's happening, but I cannot open the camera. It is telling that your video is working, but we couldn't access your camera. I don't know why it is not allowing me to access. Started by unknown. By attending this meeting, you consent to being included. Yes, definitely. I don't know what's happening.
Hello,
It is asking for
hello,
some
ma'am.
permission.
Hello, ma'am.
Yeah,
आप मोबाइल से जुड़े हैं कि लैपटॉप से?
लैपटॉप से।
तो लैपटॉप में देखिए ऊपर कैमरा और माइक दिखाई दे रहे होंगे
वो तो सब
टॉप
दिख
पे।
रहा है,
तो बस
बट
मैं
वो
कैमरे
ऑन
पे
नहीं। नहीं, it's not aligned. It's not aligned. Anyway, no problem.
Uh, uh, okay, madam, no problem, madam. We will start,
Turn
madam.
camera on, Control Shift plus O. Control Shift. Let me also try this. No, it's not aligned. I don't know what's happening.
Okay,
Anyway,
madam, no
yeah.
problem, madam.
Ma'am, shall we start the session?
Yeah, you can start. I'm sorry, but I cannot open my camera.
Okay, madam, we start the session. Okay. Thank you, ma'am. Respected resource person of this technical session, Dr. Aprajita Ojha ma'am, and dear participants of this Atal Faculty Development Program, good evening to all and welcome in technical session 5 of day 3. As the co-coordinator of this faculty development program, it's my profound honor and privilege to welcome our distinguished resource person, Dr. Aprajita Ojha ma'am, a highly accomplished academician, researcher, and visionary leader whose contribution to the academic and research community span more than 3 decades. Dr. Aprajita Ojha ma'am currently serves as a professor in the Department of Computer Science and Engineering at IIIT Jabalpur, an institute of national importance. With an extraordinary 38 years of teaching and research experience, ma'am represents the finest standards of excellence, leadership, and innovation in higher education. Ma'am completed her PhD in mathematical sciences in 1987 and has since held several esteemed positions, including Director of IIIT Jabalpur, Director and Head of multiple academic departments, and member of several prestigious national committees and government boards. Her administrative vision has significantly contributed to institutional development, curriculum design, and large-scale national initiatives in computing and design education. Madam, your contributions are truly remarkable. Her expertise spans a wide spectrum of cutting edge domains such as artificial intelligence and machine learning, deep learning, steganography, digital watermarking, robotics, path planning, geometric modeling, finite element analysis, software maintainability, and blockchain technology. She has published over 80 high impact research papers across reputed international journals and premier Springer, IEEE, and elsewhere conferences. Her scholarly work has made notable contributions to diverse fields including biometric security, computational geometry, image processing, and advanced robotics. Ma'am is also a distinguished member of leading professional societies such as IEEE, ACM, the Indian Mathematical Society, and the Indian Science Congress. Her academic footprint is equally impressive, with teaching experience in advanced courses such as deep learning, blockchain, robotics, cryptography, optimization, and computer graphics, reflecting her versatility and exceptional depth of knowledge. Her international recognition further elevates her status. Dr. Ojha ma'am has delivered numerous keynote addresses and invited talks in countries including the USA, UK, Japan, Germany, Italy, Norway, Switzerland, Singapore, and at several premier institutions across India. Her contributions to global conferences such as IEEE, TrustCom, SmartCom, and the Indian Science Congress highlight her standing as a leading global academic voice. Ma'am has also served as chief investigator for several major sponsored projects funded by DST, DEC, CSIR, AICT, and various industry partners. Her outstanding achievements have been recognized with multiple honors, including the Devang Mehta Business School Award for Outstanding Contribution in Education, received in both 2013 and 2016. Ma'am, academic journey and continued dedication stand as a source of inspiration for countless students, researchers, and faculty members across the countries. Ladies and gentlemen, we are truly privileged to have such an eminent scholar and visionary academic leader with us today. With immense respect, I warmly welcome Dr. Aprajita Ojha ma'am and invite her to enlighten us with her deep expertise and valuable insights on the topic AI for biomedical image processing. Ma'am, I humbly invite you to begin the session. Thank you, ma'am. Over to you, ma'am.
Thank you. Now I can open my camera also.
Thank you so
Somehow
much,
it
ma'am.
was. Yeah, so let me share. Thank you so very much, the organizers, for inviting me. And thanks to Gyan Ganga Institute of Technology, Jabalpur, for giving me this opportunity. Let me share my screen. Unfortunately, sharing is not allowed here. Uh, can you please allow sharing? I'm not, this sharing button is only meeting organizers and presenters can share. Yeah, now I can share. So I'm sharing the screen. I hope you can see my screen.
Yes, ma'am. Yes, ma'am. It's visible.
And you can also see my full slide, right?
Yes,
Full
ma'am.
slide presentation. Thank you. So, good evening and welcome all the participants. As I said, it is my privilege to discuss some recent developments on AI for biomedical image processing, and I sincerely thank the organizers and the administration of Ganga College of Technology. In this session, we will be discussing AI in medical diagnostics, some use cases, AI enabled early detection, and generative AI is entering everywhere. So, generative AI and the new era of medical diagnostics. So, if we look at the changing landscape of healthcare with AI, I hope you can hear me, all of you.
Yes,
Yes,
madam.
ma'am. Yes,
Your
Yeah,
ma'am.
voice is
thank you.
Yes, I'm
Thank you.
audible.
Thank you so very much. So, if you see the still we are going ahead, going with a traditional practice, where in the traditional practice we have sporadic interaction with medical professionals. I mean, most of us generally avoid going to a doctor, and only when it is very necessary, then we go to a doctor. As compared to AI enabled practices where continuous and regular monitoring, like you see your these watches now have devices. Watches are kind of devices where your health monitoring can be done. Other type of devices also exist. We are still going with reactive care model where intermittent laboratory and vital sign testing, then a lot of things are required which are overhead, kind of overhead on a patient or even on a normal person. Where in AI era, we have these facilities available. There are several advanced methods that exist, like accessible care model. We have regular and continuous monitoring and testing. We have agent management. We have many levels of care depending on the current needs that we have. Uh, Talking about medical knowledge, uh, in the traditional practice, we have extensive medical literature, which is often superficially reviewed. So, what happens that although there have been discoveries on several medicines and different methods of methodologies of treatment, but those methodologies remain in the literature. Whereas if we have AI enabled, so they regularly in AI enabled practices that they regularly incorporate new medical research as well. So this is the advantage of healthcare with AI, and the landscape of AI is changing in many countries, including India. So if I talk about AI in healthcare, so what can AI ML do in healthcare? I mean, you are all from different colleges, so you know that lab work, for example, there are a lot of things which are required for lab, like processing all those things. What is the amount of time? What is the amount of chemical that is to be added? Every such work can be properly managed using AI. We can also have treatment personalization. The same medicine may be useful for one person, may be less useful for another person. The dose can be also regulated. So treatment personalization is very much possible using AI. We also have, as I said, monitoring through wearable devices like watch. And what is very important that we have all witnessed in recent years, pandemic prediction. Like AI can help in prediction of pandemic. But in case of diagnostics, we have two different but important aspects of AI. One is diagnostic imaging, like cardiology, radiology, neuro imaging. All these are kind of images where we make use of extensive use of AI in diagnostics. Uh, when I say we make use of, we are actually progressing towards extensive use, but there are certain fields where AI is being extensively used. There is another very important thing, disease prediction and prevention. So, before the occurrence of the disease, is it possible that we assess the risk? Is it possible that we detect it early? Or can we have predictive analysis for a patient's data? So these two important things in disease diagnostic, one is image-based diagnostics, and the other is early detection or prediction of certain disease and prevention from that. These are two important aspects about which we'll be talking today. So coming to medical image-based diagnostics, my dear friends, uh, there are several AI models that analyze medical images like X rays, CT scans, MRIs, retinal images, endoscopy images, colonoscopy images. The idea is to detect early signs of diseases. If that can be done, then patients can be, his health can be monitored at an early stage of this, and disease can be suppressed. There are several deep learning approaches for computer vision. Those approaches have also been fine tuned or applied for uh, image based diagnostics, and we shall be talking about these types of image based approaches. Well, uh, if we look at, say, several if you want to see how the liver is behaving, or what is the health of liver, what is the health of kidney, in that case it is very difficult to find out methods or techniques that help us uh, in non-invasive um, understanding of kidney health or liver health. Only there are certain biomarkers that help us understand the liver type. I mean, what is the health of liver, or what is the health of kidney? So, non-invasive diagnostic using AI can definitely help in improving patients' comfort and better treatment as well. Some applications involve lung nodule in CT scan, as we shall see today. Like early lung cancer detection can be done by looking at the nodules in CT scan and checking whether those nodules are growing as cancer or not. Then breast cancer in mammograms is a well-known method. Then we have brain tumor also through MRI. Then we have diabetic retinopathy from fundus images. Several methods exist where early detection can really help the patients and also doctors in treatment. Polyps are very small growth within our intestine, and if they can be checked early, they can be detected early, then the patients can also be saved from very dangerous kind of diseases like cancer. So if we talk about lung nodule in CT scan or early lung detection, let us see what is lung cancer. Lung cancer is actually estimated to cause around 1.8 million deaths worldwide. In 2024 itself, it had a huge impact on this, which is a leading cause of cancer related deaths globally. So, lung cancer is one of the leading causes of cancer related deaths. In addition to being the deadliest cancer, it is actually deadliest in the sense that, see, if you have any other area, it can be cured, it can be detected at a relatively early stage. But lung cancer is such that it is mostly detected at a later stage when it becomes very difficult. So, in addition to being the deadliest cancer, lung cancer is also the most commonly diagnosed disease, with an estimated 2.5 million new cases that were reported in 2024, right? So, I would like to discuss particularly this very important research by Google AI by Google AI for early lung cancer detection. My dear friends, Google AI took the advantage of its um, access to. Can somebody put off his mic? I don't know if there is some mic which is already on. Can you please put off your mic? Thank you. So, just I wanted to tell you that, like Google AI, how they did perform the entire research. This is very much possible, my dear friend, here also. The only thing is that we don't have access to the data, and we don't have access to easy access to doctors as well. So I just wanted to tell you how they proceed, how they, perform the tests. So a group of researchers developed an algorithm that detected lung cancer with 94.4% success rate. That was their idea. It was a research paper by Erdia et al. End-to-end lung cancer screening with three-dimensional deep learning on low-dose chest computed uh, 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 tomography. So it was low-dose chest SCAT that was published in 2019. So this was the base paper. Making use of this base paper, where they created the three-dimensional view of the entire, uh, if there was any nodule that was growing or that was cancerous, they started looking for that using a three-dimensional deep learning. So what did they do? In, in the sequel, they started creating their method, evaluation for their method, and in 2024, they came out with their evaluation results. So they evaluated their assistive AI tool in lung cancer screening. That means early detection, they say. And they applied to retrospective randomized multi-reader multi-case studies. What is meant by this? I will tell you. The AI assistant was evaluated on 627 cases with 141 cancer positive cases. So you can see that this is a biased data. 627 and 141 were positive cases. So then they took this low dose chest CT, and then each case was read twice. One was with and the other was without AI assistance. One was with AI assistance, that means doctors were assisted through AI, and the other one was when the doctors were themselves looking at, radiologists were looking at the images and they made predictions. So by experienced thoracic radiologists, 6 were US based and 6 were Japan based, just to see that how their AI assistant is able to generalize results for 2 different ethnic population. So the study measured the reader's level of suspicion. The reader means radiologist was reading the CT scan. Reader's level of suspicion on a 0 to 100 scale, and country specific screening system, scoring categories, and management recommendation. So the country specific screening system are different. Like it may happen that if the nodule is very small, in US maybe they will go aggressive, more aggressive, but in India they may not be going that aggressive, right? So it was country specific screening system that was used for scoring, and definitely management recommendation. That means it was a team of doctor they were ultimately recommending. So let us consider these cases that were equally divided into set A and set B. N cases, 627 cases. So you could see that 124 positive were there. So cases enriched for cancer, N is equal to 330, 120 positive, right? And similarly, N is equal to 297, 17 positive. These cases were from Japan. So it is a highly imbalanced data, relatively less imbalanced for in US. So what happened that they took like reader group 1. Reader group 1 initially studied, observed set A and set B. So what is meant by set A? N, if there are n cases, n by 2 cases were given to as, were labeled as set A, and n by 2 cases were labeled as set B, right? So these were n by 2 cases. After 1 month, again those cases were studied, right? Again set A and set B, right? And so that way we had 2 n reads per reader, right? One was with assistance, one was without assistance. Similarly, you have reader group 2. So each case read twice with and without assistance in a randomized fashion, so that doctors and AI are not like tuned to see whether that case was identical or what that, just they are not biased. That was the idea. So if you see what happened, like you have AI, AI assistant read and unassisted read, right? In unassisted read, doctors uh, reading was involved, reading on a PACS viewer. Prior studies were made available to the reader. If those studies for the patient were available, those studies were made available. That means uh, what is the history of the patient? So all those prior studies were made available. And in case of AI assisted, we had an AI model inference was used, that was given to the doctor. So assisted read involved an additional series where we have AI assistance, AI makes an inference and then doctor verifies it. That was the difference. Here the doctor was the only person who checked and verified. And here, doctors were assisted by AI, Google AI. Now see, these are three images, my dear friends. This is an AI result. This is also an AI result. And this is also a third result. So let's see what is this. This is highly suspicious for malignancy. They actually found out where exactly was the malignant portion. This was suspicious for malignancy, right? Low suspicions for malignancy. And if I look at high confidence for no malignancy, see here, the AI assistance evaluation was like this. High confidence for no malignancy, whereas we had some kind of nodule that was available. So, a patient negative for cancer, where the AI system decreased suspicion of a radiologist identified solid nodule in posterior right lower lobe. So, you can see that this, the radiologist suspected that this could be a cancerous nodule. But because of the AI system's assistance, this was eliminated. So had they, like suppose they consider that, yes, this is a cancer case, all of you know that cancer, not only disease is deadly, but the treatment of cancer itself is very painful, very costly. So this patient was saved because of assistance by AI. So mind you, here AI was used only as a screening or preliminary investigation. Doctors were verifying that. So what was the high level modeling framework? You can see that here we have two types of, like, what happened that for each patient, the AI uses the current CT scan and, if available, a previous CT scan as input. And the then model outputs an overall malignancy prediction, whether it is malignant or not malignant. So the CT scans, if there were two, they were supplied to the model, and a 3D deep learning methodology was used, and that was able to predict, right? So initial scan with AI detection, as you can see on the right, initial scan with AI detection, right? Likely lung cancer detected, and that was actually found out to be true. So for an asymptotic patient with no history of cancer, the AI system reviewed and detected potential lung cancer that had been previously undetected or were called normal. So not only that, it reduced false positive, it also reduced false negative. So in the previous case, you can see that false positive was reduced here, and here you can see that false negative case was also like detected. So for early cancer detection, evaluation metrics included the area under the receiver operating characteristic curve, AUC, for level of suspicion and sensitivity and specificity of recall recommendation, right? Well, Google AI interface improved lung cancer screening specifically by more than 5%, which is quite reasonable. In both US and Japan-based reader studies, meriting further study in additional international screening environment. So no change in, one thing I must tell you, no change in sensitivity was reported in AI-enabled screening. So this, I should say, I would say that no change in sensitivity was reported in AI-enabled screening, that it shows that AI was competent enough. AI assistant was competent. Increase in specificity helps in understanding how many non-cancerous cases were identified as truly negative. So it is definitely the risk of unnecessary treatment and follow-ups were reduced, right? But a change in sensitivity shows that AI model also did not improve the test results, right, on detection of people who actually had cancer, true positive cases. So remember that it is both ways, like no change in sensitivity tells something which is positive, but it was in case of like true positive cases, it could be definitely, it could not help. Now, so let us, if we talk about cancer detection or cancer screening in India, let us see what is the Indian landscape. It is one of the most common cancers among Indian males, and it accounts for 8% of cancer related mortality. Why? Because in India, as you know, that smoking is more common amongst male members. Lack of resources such as access to computer tomography, scanners, and lack of organized infrastructure that is required for an efficient lung cancer screening program is also a major cause that lung cancer is most common among among males in India. Not males, I mean, it's most commonly occurring cancer. Uh, there is one thing which is very of high concern: high prevalence of tuberculosis and resultant false positive on low dose CT dilute the value of an ideal screening test. What happens that in many cases in India, TB still is a great concern. And because of high prevalence of tuberculosis, when CT scan is performed, then cancer is not detected. So that makes patients' conditions more like worse. So in lung cancer screening, if AI can be used, it will definitely be reducing the risk in populations in India, also not only in India, but in other developing countries, because we do not have such high infrastructure everywhere. Like a CT scan is not very common in India. What I mean to say that commonly available, right, like in advanced countries. But I would like to specifically mention AI-based lung cancer screening in how AI has been helping in India. So Karnataka is using AI. So 19 district they perform like AI-based lung cancer screening. It could benefit over 1.4 lakh patients. Similarly, AI-based lung cancer screening in Karnataka detected 133 lung nodule malignancy and nearly 3,000 TB presumptive cases in last 9 months. That is what this, like, from initial 20, this you can see October 2023, and this was published in 2024. Like in 9 months, what their study suggested. So, lung cancer is one important thing. The second is a colorectal cancer. And of all cancer deaths so one is lung cancer, which is very important, needs to be identified at an early stage. Google AI researcher gives us some directions of research because there is no dearth of deep learning model. The only thing is how do we perform those experiments? I believe that academic collaboration between medical professionals, medical colleges, and technology colleges or technical colleges is important. Unless we do such kind of collaboration, I don't think we will be able to uh, progress in this direction. But I see that there is a lot of scope. Startups are coming up and they are helping doctors They're helping academicians in bringing the products from mine to market. So through them, experimentation, many things are possible. So I know one such a startup which is doing very well, and it was ranked among top 30 AI startups. They're working on liver, for like liver health, for lung cancer, all these things. And there are many such startups which are working on this. The next is the colorectal cancer. As I said, that of all cancer deaths in people under age 50, colorectal is now number 1 in men and number 2 in women. So, colorectal cancer is the third most commonly occurring cancer type and second most common cause of cancer death globally, as per a report of International Agency for Research on Cancer, which is really very alarming. So there are about 1.9 million new cases of colorectal cancer and more than 9 lakh deaths due to colorectal cancer worldwide each year, which is a big number, right? People don't know because of their eating habits, because of many other things, negligence, this colorectal cancer is like created. So colorectal cancer usually begins as a small growth called polyp on inner lining of colon or rectum, like the one that I showed here, right? Here, this part, right? And it usually, like over time, some polyps can turn into malignant tumors or some can be normal. Uh, Wireless capsule endoscopy, which is not very common in India, but it is a cutting edge non invasive technique used primarily to examine the gastrointestinal tract, especially areas that are very difficult to access with traditional endoscopy methods. So, while it is most commonly used for small intestine, its use for colorectal cancer detection is growing due to advancements in imaging technologies and also AI technologies. Because unless you send your camera through wireless capsule endoscope, there is a capsule that a person swallows and it travels through the entire body, the digestive system and then everything, and finally it comes out of this rectum. So then it records the entire, uh, like right from the top to the rectum area, it records everything. So now, because of imaging technologies are having advancements and also AI is having advancements, this has become a popular, like very popular the in developed countries, and it's is becoming uh, one of the emerging areas of application. So if I look at this, what is it? As I told you, tiny capsule is followed by a patient equipped with a camera and battery source that records the video. And then WC videos are 8 to 10 hours long. And for a physician to inspect, it is quite tedious, like 8 to 10. Physicians are very few. So then AI enable video inspection can definitely help in this case, and that is what happens. But what are the challenges? Technical challenges are like there is limited power in capsule, low resolution images also sometimes, lower abnormal lighting condition, and then there are clinical and diagnostic challenges as well, like variation in gastrointestinal abnormalities in the form of texture within the within our esophagus, within our intestine. There can be several texture, color, shape, size, like bubbles can be there, or they, because of the camera and lighting condition, there can be some shiny areas which become very difficult for us to examine. Then there are data challenges because we don't have uh, publicly available data sets to train our AI models. Uh, and there can be variation in images due to different apparatus, different type of wireless capsule endoscopy, wireless capsules, and definitely unavailability of annotation makes it more difficult. Let us see this. These are some of the images which are there, and you can see that many of them are looking same, but this is what is polyp. This is polyp. We will be talking about polyps today. So polyp segmentation has been a challenge, and there can be large variation in its visual appearance, as you can see here. Now, this is something quite close to polyp, right? But so there can be visual difference in visual appearance, and then endoluminal folds can be there. There can be sometimes, within the intestine, there are some folds that makes it difficult to locate. So, and presence of other objects like bubbles, acid, food, flares, several things are there. So, for example, these are folds. I tell you. Just want to show you. So you can see the polyp here. Yeah, you can see the texture here is different, right? That makes it like distinctive. Yeah, so that is what I wanted to tell you, that in general lighting condition, it is very difficult, right? In blue light, it was able to show the texture. So going further, uh, we have done some research in this area, and an efficient AI model has been created, developed, that demonstrates uh, an edge over existing approaches because there are two important things. One is that even the very tiny polyps we are able to locate with high precision, which none of the previous cases they studied on this. And second thing, that uh, this here we developed a specific kind of attention module. That attention module provided this encoder decoder model an edge over other, or like other models, right? So two important things. One is early detection, which was not done. Any study was not, like, there was no such study, but we were able to do it. Second thing was that a specific attention module uh, to help detect polyps at early stage. So this actually outperformed 13 state-of-the-art polyp segmentation methods. And these were very published in very highly reputed journals from different from different publishers. And we used 5 publicly available data sets, and the proposed model demonstrated good generalizability also. Like, as I told you, that if the model is doing good on one wireless capsule videos, it should also do good on other wireless capsule videos from other manufacturing companies as well. So it was able to show validation on other data sets as well. It is basically, it can be very useful for early cancer detection. In fact, one company approached us also. They were trying to they wanted us to sell the rights, copyrights. Which we did not do because we wanted to make it open source. So network polyp segmentation that exploits a network for polyp segmentation that exploits both the convolution and involution operations. So we actually applied convolutional layers, and we applied involution layers as well, just to take care of the long range dependencies. Then we also added one statistical feature attention block that was introduced for improving the polyp region approximation. And then an anomaly boundary approximation module was deployed. That actually helped in identifying the boundaries of the polyp. So as you can see that this is an encoder-decoder architecture where we have coin block. So what is coin block? It is convolution involution equipped attention module. So if I look at the detailed architecture of CoinNet, it appears to be complex, my dear friends, but it is not that complex. So we have, suppose you have a backbone. Let us take the backbone of DenseNet 121. We took DenseNet 121. At each of the 4 stages of DenseNet, we took out the features, right? Passed it through a coin block, which is an attention module, right? So these features were further enhanced. Then what we did was that we again passed it through a reverse feature fusion block that I will discuss a little later. And so this was the encoder part where coin block was used. Coin block, as you can see, was using 2 convolution blocks, 1 involution block, and then again 1 convolution. And then this was further making use of a residual connection. We added this. And then we have a statistical feature attention block. So statistical feature attention block is nothing but this, where the input feature can be image like input feature, and then we used mean, max, like variance and ST. That was done through the depth of this. For example, if we have say 6 channels in the image, then from those 6 input image, then all throughout the 6 channels, think of the pixel at 1 pixel position. Suppose we have 6 channels, right? Right, these 6 channels are there. Sorry. Let me take 4 channels only. So suppose here is a pixel position. Across this pixel position, let us take the mean of pixel values. Let us also take the max of pixel values, the variance of these pixel values, and then standard deviation. So we will have 4 different such channels that will be created. So those 4 channels are then passed on to a convolutional block with 1 cross 1, 3 cross 3, and 1 cross 1 convolution. And then this was then merged with the input, refined with a convolutional block. So this is what is my coin block. Let us now go to encoder part. So you can see that the encoder is relatively simpler. But if I look at the decoder, in decoder, we had, this is a partial decoder, where from each stage, we were sending the input. As you can see that from each stage, we are sending the output of coin blocks, to the input of at different levels of decoder. So these are different levels of decoder. And finally, what we did was that we applied a convolution block. We also applied several segmentation. Sorry, we applied anomaly boundary detection block as well. So it is designed to capture spatial features and long-term dependencies, both. It also uses a receptive field unit to simultaneously learn multi-scale features as well. Thus, the coin block was able to integrate the advantage of convolution, involution, and statistical feature attention, right? And receptive field unit was able to extract salient patterns from feature maps learned by backbone network. Now, receptive field block, what is this? This is actually inspired by the structure of receptive field mechanism that is in human visual system. What happens that human visual system makes use of, say, one cross, some kind of mechanism that is similar to 1 cross 1 convolution, 3 cross 3 convolution, 5 cross 5 convolution, right? And then that is passed on to, they are all combined. So you can see that a pyramidal structure of uh, of features at different scales are presented. So that is the idea of receptive field block. I hope this is clear to you all. Involution. What is involution? Involution is another kind of operation. In a typical convolution, if you remember what happens, each filter performs a local receptive field. So if you have an image, right, you have a filter here which operates on this part of the image, right? So if the suppose the image, if the filter is say 101, 2 0 minus 2 and then 101, suppose this is the filter, right? This will be applying only on this part. So if the image is say having values 3 5 7, 4 5 3 7 and 3 3 7, then this 3 will be multiplied with 1, 5 with 0, 1 with 7, 2 with 5, 3 with 0, and so on and so forth. And you get one value, right? Finally, when you multiply, then sum them up, then you get just one value. So in a typical convolution operation, each filter performs a local receptive field depending on the size of the filter by sliding over an image input. So then the same filter slides here, and so on and so forth. So unlike convolution, involution makes use of distinct filters specific to each pixel position applied across the channel. So here you can see that here the filter value is all, as you can see that the filter value is fixed in case of convolution. Now, involution does what? It makes use of distinct filters. They are specific to the location of each pixel, right? How does it do? Let us see. How does it do? So let us imagine this pixel. This pixel is suppose is having a neighborhood 3 cross 3 pixel neighborhood. Let me take. Now this 3 cross 3 pixel neighborhood, as you can see, what it is doing, basically, I'm generating a kernel related to what is the neighborhood of this pixel. Okay. So what I'm doing is that I'm making use of a 1 cross 1 cross m square. How does it? So suppose this is 3 cross 3. So it is m square is 9. Right? This is my m square. So 3 cross 3, I will take 3 cross 3 neighborhood. So m square is 9. That means m is 3. M is 3. Okay. Now what I will do is that I will be making use of this, like this neighborhood, applying you are basically making use of this neighborhood to create a 1D, like location specific kernel, as I said. So each spatial location has its own kernel generated through a learnable map. What is that learnable map? That learnable map is that I will be making use of a from this pixel, this is kernel generator is a learnable map that generates this to a 1 cross 1 cross m square output, right? And then that 1 cross 1 cross m square output is further reshaped into m cross 1. So I hope you have understood what I'm saying is that we are basically, what we are doing is that we are creating a function that is machine learned to create for this pixel. If suppose I wanted to create a filter of size, say 3 cross 3, which is say m square in this case, right? So what I will do is that I will be mapping this portion through a learnable kernel to 1 cross 1 cross 9 size, and that 1 cross 1 cross 9 size is reshaped to 3 cross 3 cross 1, right? And that becomes my involution kernel for this pixel, for the first pixel. Similarly, if there is a channel, the second, at this pixel position, the second channel, think of the pixel position and the second channel, you will be creating a second kernel, similarly third kernel, and so on and so forth. After the kernel has been generated for each of the channels, then we apply the kernel operation, and then we get a 1 cross 1 cross C image. So involution is a, if I look at involution, it is basically looking for self similarity, and in a way it is a self attention map. So filter weights are then dynamically generated for each spatial location based on input. I hope this is clear to you. Please don't worry if it is not clear to you. We will share with you the lecture slides, and also if interested we can share with you the available literature. If I look at the coin based attention, you can see the first is output from stage 1 of backbone to the encoder. This is stage 1. Output from the initial convolution layer. This is the second. If you look at the last one, I seek your attention on the last one. On the last one, you can see is the most refined. So this is the polyp. This is passed through a kernel. This is passed through an attention block. And you can see that these are the most refined out of this, right? If you can see that we are getting a more refined version. If we look at the comparative performance of coin network with state-of-the-art methods, as I told you that we use 13 different methods. So as you can see that the DICE score, the IOU, FM, SM, EM, MAE, all those were all much better than many cases. This included transformer based also, very state of the art at that time. If I look at on unseen data, this was on the CVC clinic where it was trained and tested, but it is totally different data set, totally, where we did not train the model on these data sets. There also the performance of CoinNet was found to be much better than many others. And if we look at the qualitative performance also, you can see that this is the input and this is the ground truth. So compared to many other methods, this CoinNet was giving better ground truth. This is also the ground truth. You can see that many other methods were performing well, but some were missing this part, and this was much better. So qualitative results were also found to be good. What was very interesting was that when we performed small polyps, like less than 2% of the total image size, so risk associated with polyps is determined by their size, number, histology, and the presence of certain genetic mutation. And if the polyp is detected at an early stage, the risk of cancer can be drastically reduced. But small polyps have the risk of getting missed by CAT system. Kyun? Because as you can see that they can be folds sometimes, or they can be like this one. This one is appearing to be, say, some shiny light, whereas this is polyp. So there also, like our model was able to perform much better than many models, and that was the reason in point, sorry, not 2%, it was 0.02% of the image area. CoinNet outperformed state-of-the-art methods on small polyp segmentation. So this result was published in Transactions, IEEE Transactions on Medical Imaging. You can see that on small polyps also, like here the performance. This actually missed. This created a large one, but it was able to detect very uh, precisely. So I hope this part is you got some interest in this part. I would like to next discuss something on diabetic retinopathy that our group is doing. So diabetic retinopathy, this is also a leading cause of blindness all over the world. And this is caused by diabetes that may lead to visual impairment also. An estimated 77 million people in India have diabetes, and 12.5% of those with diabetes have diabetic retinopathy. As you can see, fundus images with DR severity, this is no DR, and this you can see that this is a very severe case of DR. So that creates blindness. So presence of retinal diseases can be examined using fundus images. Like this is a healthy blood vessel, and here tiny blood vessels leak fluid into retina. That makes it eye with retinopathy. This is a normal eye. So that is why the vision is lost. But what are the main challenges in AI-enabled ophthalmic disease detection? One is frequent co-occurrence of multiple conditions in fundus images. There can be multiple problems. Tiny features like micro, you can see so many tiny features that are there. A small size hemorrhage also, they're difficult to spot, especially in the early stage of diabetic retinopathy. Even doctors say that they miss some of the small size hemorrhages. Then AI overlapping lesion and abnormal vascular structures make manual screening very difficult. But AI models trained on single ethnicity, so that one thing that is important in Google AI research that we discussed, that for lung cancer, they use two different ethnicity. So mostly the AI model that have been trained on single ethnicity. There is concerns about their capacity to function with a similar performance across ethnicities. Class imbalances also in data sets. And then what is important is making the model clinically viable. That requires interpretability of their predictions and generalizable performance. Generalizable means uh, across different fundus image capturing devices, across different ethnicity, it should perform well. So what we did last year was this very simple network that we used, an interpretable dual attention network. This dual attention network used dual attention. As you can see, this is one attention, this is another attention. And we started with a backbone network for extracting low-level features, and they were then further processed. So what are these bidirectional spatial attention block that you can see on the left-hand side? And then we have self-attention based technique to capture spatial contextual information. Row-wise and column-wise pooling was performed on feature maps. Then we have a CPA block that suppresses redundant and insignificant information. Sometimes some information is simply redundant. So that was there. So it redistributes channel information so that redundant information can be avoided. So when we applied this dual attention network, which is IDA network, its classification performance was outstanding. On different models, IDNet was able to perform well. Not only with the AUC, the kappa score, and accuracy, the flops also, you can see that IDNet was quite close to many things, although this was having very high, relatively higher flops, but it was able to improve the accuracy, AUC, precision, recall F1. But this was at the cost of higher flops. By higher flops, I mean the floating point operations that are required to for one pass of the image so that it is able to detect through the network. Then on cross data means on unseen data also, it was able to perform much better. As you can see, the heat maps obtained from IDNet, right? It was able to identify exactly where is the anomaly. But as I told you that nothing is more important for doctors or for medical professionals than interpretability of the model. Like when and how a model will fail and why the model thinks that there is a lesion, there is something abnormal within the fundus images. So interpretability of models is very important. So uh, that definitely enhances trust on AI systems. And currently, AI researchers are doing a lot of research on improving the trust of AI systems, right? Um, I'll take a small break of 2 minutes for water. I'll come back. Thanks for waiting. Yeah. So idea is that how do we improve the interpretability of the model uh, that means when it is taking a decision, when it is giving an output, how this output is obtained, what is the reason that a model says that there is a there is a lesion, and where exactly is the lesion, and therefore this image is having some lesion, right? So this is important, interpretability. Uh, it also improves clinical acceptance because AI model's decision affects human life, therefore interpretability of model decision is even more important in medical domain. Let us take this example of IdeaNet interpretability. Lime, using Lime, which is a local interpretable model agnostic explanation. So we used Lime based explanation. So as you can see that this was the image, and it was found out to have some kind of abnormality, right? So it was classified as having abnormality. But if the doctor annotated abnormality was this, and the abnormality that the model found out, our proposed method found out, was pretty close to that. If you can see in this case also, this is a ground truth. Many of the existing methods, which were very highly competitive with the proposed model, we found that they were, uh, in some cases, they were falsely detecting abnormality. And our model also, in some cases, was failing. But it was much better than previous cases. What was important in this IdeaNet was that for tiny size, for early detection, tiny size lesions, it was able to perform much better. Like this is an original image, you can see ground truth. It is very difficult for doctor to determine, right? Doctors told that it was difficult for them to determine that there is some abnormality in this image, right? This is something which is definitely showing abnormality. But let us consider this image. It is very difficult to identify, but our model was able to identify with like very high confidence. This is a missed case in this, in the previous, like this work lat and cabinet, these are two AI models, so it missed it, whereas our model was able to do it like very well. That was the idea. So in tiny lesions, it was able to work very well. Now, what is Lyme and how does it work? So Lyme, my dear friends, I seek your attention. Suppose you have um, a model, right? The model has been trained on some data. Okay. Now you want to find out why a model has classified, say, this image as having some abnormality. Why? I mean, so in that case, what we do is, let us take a very simple example where we have, suppose, a input which is having just 10 features, x1, x2, x10. Suppose you have only 10 features. Now this input has been already classified, right? Suppose this is belonging to class 0 or class 1. 0 means no abnormality. 1 means suppose there is some abnormality, binary classified. So suppose this has been classified as 0. What we do is that we randomly, from these 10 features, we randomly mask out some features like x1, x2, then we will do 0, 0, x5. That means we have masked out these x3, x4. x1, x2 is done, x3, x4. So this another sample is created, right? This also is definitely created from here, but it is of class 0. In this way, by randomly creating masks, we will be creating, suppose these are 10 samples, suppose we create such new samples from this already classified uh, input vector. We suppose we have created, by masking out some of the elements, suppose you have created 50 samples, right? Now these 50 samples we will be passing through the deep neural network model, right? We will be passing it through this. Okay, these all of these 50 samples. All right. And we will be getting predictions, whatever prediction, whether it is class 0 or class 1. So there will be many of these vectors which will be classified as 0 class, and many vectors will be classified as one class, right? So what we are doing, that we are creating perturbed instances from the original instance, and we are passing it through the neural network, which is a classification which has been used as a building classification model, and we will find out what is the likelihood that this what is the likelihood that this image, for example, here what they did was that they took out some of the portion of the image, created one sample, created another sample, created so on and so forth, several samples. For each sample was passed on to this, and then they finally created a score. That score, that this the model was confident that this was of class 0, this was not of class 0, so this was of class 1, and so on and so forth. After this, what they do is that these 50 samples are assigned the labels created by models, right? And then they are passed through a interpretable model, like suppose think of a linear regression model. Linear regression is very simple, easy to understand model, right? Where you have two types of like samples, and a line which is distinguishing between these two types of samples is created. So anything above this line is a belonging to class 1, anything below this line is belonging to class 2. So we can say that for example, suppose this line is y is equal to x line, so here the x coordinate was more and here the y coordinate was more, right? So that is why we can say that the x coordinate is more responsible for belonging to this class, and y coordinate is more responsible for belonging to this class. I hope I have made my point clear, because I cannot see your uh, messages, so I'm just moving ahead, and then I'll give you some time to discuss. Then in that case, what happens, that you can see that when it is passing through a interpretable prediction model, then we find out, okay, these are the most important features in this image that classify this to become of class 0 or class 1. So it actually tells us most important features. Just like I told you that x coordinate was more here below this line, and y coordinate was more on this part of the line. So similarly, those features which were more important are highlighted. This is what is line. So select an instance for explanation, consider an instance image as the sample, generate perturbations, create a set of perturbed samples by slightly modifying parts of the image. Prediction on perturbed image, get the model's prediction for each of the perturbed samples to infer which part of the input were more influential for the model's decision. Fit a local surrogate model. By surrogate model, I mean that model which is simple to understand. Or fit a simple interpretable model like a linear model or a decision tree to the model's prediction for perturbed samples. This surrogate model captures the given deep learning model's behavior, right, locally. Lime can be used for text, Lime can be used for tabular data, and Lime can also be used for image inputs. And that's why Lime is one of the most frequently used uh, model. But let me tell you that we have experimented with Lime for different data types, but for medical, it is doing well. For other data, image data, it is not doing so well. For example, in case of agriculture data, we didn't find that my Lime was very useful in model interpretability. Dimensionality needs to be reduced for inputs of large size, because if the input image is say 256 cross 256 and you create 100,000 samples, and so Lime is very slow in that case. Yeah. And then Lime calculates the effect of each feature on the prediction of AI model. So that is why we used Lime. Okay, so in summary, IdeaNet was able to enhance detection of small size DR lesions. That is very important, my dear friends, because early detection is an important step in medical profession or in healthcare. Improve diabetic retinopathy severity grading performance. I mean, to estimate what is the severity of diabetic retinopathy, we were able to prove much better performance, improve the performance of AI models. Then interpretability was much improved. Well, challenges arise in detecting lesions that are composed of only a few pixels, like 4, 5, 10 pixels, and that blend with background color. So that is the problem, and that we were able to solve to some extent. Now, we have also worked on using a type of cycle GAN. We created our own cycle GAN model, and for image synthesis on the right, you can see we compared with different GAN models, and this was giving much better results. Because you can see that the FID score, which is very important for generative models, was much lower than many others in both the training data sets. And in summary, effective handling of class imbalance we were able to do because we generated some synthetic samples that were very real, looking quite realistic. That helped in improving feature extraction with statistical and multi-scale attention. We applied statistical attention here also. It the quality of images were very high quality. Well, there is a scope because we were able to generate uh, images with very small size lesions. So that also we showed that how it is able to give us refinement for generation of images because we were able to generate more images with very small size lesions. So it improved the performance of any general model. We used our model, we used others' model as well, and we showed that making use of data augmentation through GANs, DISTA cycle GAN, we were able to prove much better. We were able to improve the performance of AI models. So in summary, my dear friends, early detection of disease helps save human life and provides better health care. Sometimes the diseases are not caught by humans in their early occurrences, and so AI-enabled early detection has shown promising results. So we discussed in this lecture three case studies: lung cancer, intestine-related problems, and diabetic retinopathy, where AI shows potential for clinical applications. Trustworthy AI-based diagnostics is the current trend, and therefore multimodal AI models are models are being trained on not only for classification of images, but also classification along with the doctor's interpretation. So doctor's interpretation is in natural language, and then you have image. So multimodal AI is the need is the, basically is the current trend. And then generative AI support can definitely help enhance the computer aided diagnostics. With this, we have several references which we've used here. We are doing further research on these domains, and but results are not published yet, so we have not discussed those results. Some slides are taken from the presentation slides of Dr. Sameer Jain and Dr. Amit. Now he's also Dr. I'm sorry, Dr. Amit Bhati. Both are our students, and where our students they have graduated from IIITDM Jabalpur, and Dr. Sameer Jain worked with me, and Dr. Ayan Sheel and Dr. Amit Bhati worked with Preeti Khanna. So we have a good image and vision engineering group where all the students interact with each other, they collaborate, and uh, they create excellent models. That is all from my side. Thanks. And if you have any questions, please feel free in asking.
Thank you, madam.
Thank you.
Participants, if you have any doubt or any question, kindly ask. Kindly raise your hand or ask the question.
Thank you. Thank you, Anandji. Thanks, all the participants who are found it interesting and valuable. Thank you. Thank you so very much. I'll be sharing my slides with the organizer, Dr. Javed Akhtar and Dr. Vimi Pandey. Oh, Preeti is also there. Dr. Preeti Rai was also our student. So somebody has Manikandan, somebody has raised hand.
Yes,
If
ma'am.
you want to,
Manikanandan.
yeah, Manikanandan. What is your
Yes, ma'am.
question?
Shall I?
Yeah. Yes, please.
Actually, I eager to know about so how this Google AI is detecting this lung leak cancer and all, ma'am. Ma'am, I really want to know the recent trend that we observe. Maybe this is and all only maybe the resources that we get only from the journals or something, or do we have any separate like Google Skills kind of platform that we can enrich our early detection, like something like biometrics and healthcare or IoT. Any useful links that you can share us to know about the recent trends of this particular early detection modules, ma'am? Any suggestion
These
you
are all
recommend?
recent only. These are all recent only. Like Dista, these are all recent. So what we have done is that we have collaborated with medical practitioners also. And so in the first case, there was a medical professional from Poland in case of wireless capsule endoscopy. And in case of diabetic retinopathy, we collaborated with uh, ophthalmologist here in Jabalpur, in the city of Jabalpur. So we have to collaborate because unless we take their like validation has to be done by doctors only. Uh, AI results. How do we know that this result is actually giving us the true positive case, right, or true negative case? So you need still need assistance from doctors or medical experts. Opinion is also required. Regarding Google AI, they did not reveal the model because um, they are commercial people. They did not reveal the model, but I think that the model is not what is very important is that the methodology that they used, that they used two different sets of doctors from two different countries, Methodology, you will find lot of literature in like on Google Scholar or in IEEE Explore or in Elsevier. You will find lot of literature and very sophisticated models have been created. So I don't think that Google AI, they might have, because they have access to data. So we have access to literature, right? But the data is limited. That is the reason the models that we generate as researchers, when we say we, means researchers all over the world from academic institutions, they have limited access to data, and so their models are very powerful. But if only when the data is made available, those models can be tested and further validated. Yes. Any other?
Shall I follow up, ma'am?
Yes, you can.
Ma'am, actually, this question arises because exactly I'm working on the early detection of an internal organ failure, ma'am. So, particularly a medical device. So, my research field is same. But where I'm getting
So
a
which
very
which
tough time
internal
is,
organ? Which internal organ?
ma'am, particularly exactly with lungs and parenchyma and heart. I'm working on, ma'am, and that
Too
is
many.
basically a general exam.
So don't make too many. In fact, every organ has a different kind of specialty, right? Like if you do for kidney, it will be altogether different, visible. For liver, the structure is very complex. For heart, it is even more complex. So please
Exactly.
focus on one organ first. You are thinking of a
Exactly, ma'am.
medical device. Yes, please tell me. Go
Sure,
ahead,
ma'am. So
please.
we are initially we are concentrating on heart, ma'am. So in that
Hmm.
way, so we got a pattern of general examination. But the difficulty in the research methodology we had in terms of data sets and working with this kind of models, particularly, ma'am. So the moment you said Google AI Assistant, I'm very curious. That's why the questions came regarding the model.
So models you will find on like research papers, journals. You are from which? Are you from an institute or industry? Are you from an academic institute or industry?
No, I was in HCL Technologies in a medical device, and now I'm working in a full time, like part-time research scholar and an academician.
Okay. So you are having access to journals then, right? So
Yes,
journals
ma'am.
are can give you can get a lot of sophisticated models. You can begin with uh, like recently published models, and then you can improve upon them. That is possible.
Perfect, man. Thanks for the brilliant answers, ma'am.
Thank you. Any other?
Good evening, ma'am.
Good evening.
Ma'am, nowadays explainable AI is the extension of AI tools.
Shailesh, may I know who's speaking?
My name is Shailesh Khaparkar. I'm academician from Gyan Ganga Institute of Technology.
Okay, fine. Yes, please, Shailesh, please tell.
Nowadays explainable AI is, putting more impact to the AI tools.
Yeah.
So can you explore in brief, ma'am, about explainable AI?
That like I told you, this lime is one method, locally interpretable model agnostic methods. So there are other methods like GradCam or GradCam plus plus has been used very uh, most extensively. But if we come to medical domain, no single method can be treated as very good for different image modality. For each image modality and for each type of data set, people have realized that we want to have better explainability methods. So a lot of research is going on explainability of AI models. Yes. There are two types of
Okay.
methods. One is model agnostic and one is model specific. So GradCam is model specific. That means it is based on the model. Whereas model agnostic like Lime, it works for all
Yeah,
models.
yeah.
Whereas model specific like GradCam, for each specific model, the like it depends on the if you remember, it depends on the uh, mm, the it does backpropagate class activation map. So it depends on the activation map, and therefore it is model specific. So people are working on that. Yeah.
Okay, thank you, ma'am.
Thank you. Thanks for the question.
Thank you so much, madam. It's a very wonderful session, madam. I request to all participants kindly switch on your camera for take a photographs of this particular session. I request to
Okay.
all participants.
Yeah. This is what is mandatory in people. I think Atal FDP is something.
Yes, yes, madam. They
Yes.
are asking.
Yeah. Yeah.
I request to all participants kindly switch on your cameras.
I can see many familiar faces here. It's a very nice to see you all. Thank you.
Thank you so much.
Thank you, madam.
Madam, Vimi, madam, over to you, madam.
Okay. Thank you, ma'am. Thank you very much, Dr. Aprajita Ojha, ma'am, for delivering such an insightful, informative, and enriching technical sessions. On behalf of the organizing team of this Atal FDP, as the co-coordinator, it's my privilege to extend our heartfelt gratitude to you, ma'am, for sharing your deep knowledge and valuable perspective on AI for biomedical image processing. Your session has truly enhanced our understanding of advanced concepts in AI and its transformative applications in healthcare imaging, especially topics like cancer detection, retinopathy, and early detection of diseases. The clarity of explanation, the depth of your research insights, and the real world examples you shared have greatly benefited all participants. Once again, thank you very much, Dr. Prajita Ojha ma'am, for gracing this occasion with your presence and for making it so impactful. Thank you so much, ma'am.
Thank you. Thank you so very much. Thanks all the participants. Thanks the organizers. Thanks everyone.
Thank you, ma'am.
Okay, I take your leave then. Thank you.
Thank you.
Dear all participants, within a couple of minutes, we will start our second session.
बंद करनी
हाँ. Mrinal madam. Hello. Dr. Mrinal madam. Hello. My
Can you
voice
hear
is
me?
audible to everyone.
Yeah.
Dr.
Yeah.
Mrinal madam.
Yes,
Okay,
yes.
shall we start, madam?
Yes, we can start.
Okay, madam. Okay. So it is my honor to privilege to introduce our distinguished resource person for the second session, Dr. Mrinal ma'am, a globally recognized leader in artificial intelligence and model-based system engineering. Dr. Mrinal ma'am brings with 24 years of rich experience spanning academia, advanced research, and extensive industry collaborations. She currently serves as a head industry contact at a Symbiosis Institute of Technology, Pune, Maharashtra, where she has played a transformational role in bridging gap between the academia innovation and the industrial relevance. Under her leadership, Symbiosis Institute of Technology has witnessed remarkable progress from the established more than 300 plus strategic alliances with reputed organizations like Bajaj, Tech Mahindra, Philips, and many more for formalizing 100 plus MOUs that strengthen education, research, industry integration. Mrinal ma'am published 85 plus publications, research paper in the reputed journals such as SCI, Scopus, Web of Science, and UGC Care, multiple patents as well as the prestigious grant in streaming is domains such as automation system, sensory, artificial intelligence, smart city as well, and the advanced healthcare technologies. Her dedication to model based system engineering, coupled with her expertise as a consultant, author, speaker, MBD training, continues to inspire thousands of professionals as well as the student also and the young researcher across the India as well as abroad. Today we are truly fortunate to have her with us delivering the nightful session in the Atal FDP. So dear all participants, please join me in warmly welcome Dr. Mrinal Madam. We look forward to learn from your expertise. I request to ma'am, please start the presentation. Thank you.
Yes. Good evening, everyone. I hope you are able to hear me and see me. It's wonderful to have you. And first of all, I am grateful for the organizers to providing me this opportunity to interact with all you audience. Basically, and yeah, I must mention, thank you for the wonderful introduction. Uh, so, this, so let me share my screen. Uh, just a moment. Is my screen visible?
Yes, ma'am.
Yes,
Yes,
ma'am,
ma'am. It's
it's
visible.
okay, madam.
Perfect. Yeah. So as rightly said, my whole intention, of course, while doing the research, is on how this is applied to the society, how the research is useful to the industry, and how we can, um, not only the research should be in the papers, but it should also come out in the patents, and then there should be some technology transfers, and ultimately it should be useful to the common people, common society. So today's topic for my talk is AI based healthcare using IoT and deep learning models. So let me tell you, when we talk about AI, most of the speakers might have spoken about how AI is enhancing every particular vertical. Now I'll be focusing on some of the research which I have done with my PhD scholars and my research group over here at Symbiosis. So we have done a lot of good work in prediction by using deep learning models. So today my focus would be on brain dysfunction, epileptic seizure prediction system using deep learning models. The flow would be that we'll be first talking about what is actually epileptic seizure and what are the types of epileptic seizures. Then we'll be talking about EEGs, and then we'll be focusing on deep learning models, which kind of models we did a lot of experimentation. So as I said that we are a very good research group which we are working on different models, and here I'll be talking about three models and then I'll be concluding. So when we talk about epileptic seizures, most of you might know about it. That epilepsy is what? A neurological disorder characterized by recurrent seizures. So what are seizures? Seizures are caused because of the abnormal electrical activity inside the brain, leading to range of mental and physical symptoms. So early detection is always better. So you can say there is normal brain activities and there are abnormal brain activities. And if at all the abnormal brain activities are detected earlier, a lot of good things can be done for the patient. Preventive measures can be done for the patient, right? So in healthy brain, the electrical signals which are traveling is controlled and organized manner. These signals are responsible for various brain functions, like be it your thoughts, your movements, sensory perception, etc. Now, if it is an abnormal brain activity, say during a seizure, what happens is an abnormal electrical activity occurs in a specific part of the brain, disrupting the normal brain function. And what happens because of this is this abnormal electrical signals, they spread to other parts of the brain, leading to various symptoms, could be mentally as well as physically. So these are like what are the main focal, just yeah. So focal onsets for the seizure, there are simple focal seizures and complex focal seizures. So there are two types, I would say broadly we can categorize it as simple focal seizures. So what happens here is the seizure affect a specific area in the brain and may cause symptoms such as say tingling, numbness, or muscle twitching. So this is very simple, but there are complex focal seizures. You can see in this diagram that the seizures can affect consciousness and causes symptoms like confusion while you are taking a decision, hallucinations, or loss of awareness. So these are the major complex focal seizures which are very serious. Now, what are the generalized onset seizures? There are like, tonic clonic seizures, absence seizures, myoclonic seizures. Now see, when we started this work, we did an extensive research, what other researchers are been doing. And in our institute, we have a medical hospital. So we also had an ecosystem wherein we can very easily talk to the doctors, discuss about what are the issues currently they are facing in diagnosis, prognosis, and then the clinical treatment. So tonic clonic seizures, what are these kind of seizures? We got to know about these seizures. These are characterized by loss of consciousness, muscle stiffness, and jerking movements. Then the absence of seizures. So these seizures are brief period of, suddenly you go blank, or suddenly a person may appear unresponsive. Someone is talking, but the person is unresponsive, and that is not intentional, but it is because of this seizure problem which has been caused. Right? Myoclonic seizures, these are involved in, sudden muscle jerks that may occur in single limb and which may not allow you to move your body, or maybe throughout your entire, maybe limbs, or throughout your entire body also, which may be as if a frozen condition. So so these are the types. Now what are the symptoms, what are the early symptoms, and how we can help the patients to understand that, oh, these are the early symptoms, and if at all the symptoms are there, then you need to go for a test, you need to go to see your doctor. Early is always better rather than going it, worsening the conditions. So these are like early symptoms which are sensory changes, then there are certain cognitive changes, then there are motor symptoms, as I just now said about not only sensory changes, which is hallucinations, tangling sensation, or change in taste or smell. There are cognitive changes. These may include confusion, uh, dis dysfunctioning while you are speaking, maybe not able to speak or not able to understand the language. So this is cognitive related change. And then there are motor, as I said, emotional changes also. People with epileptic seizures, or people with epilepsy may experience feeling of fear, continuous fear, anxiety, depression. So these are the early symptoms. And what are the risks? There are several risk factors, and what are the causes also. A, genetics. So certain genetic mutations can increase the risk of epilepsy. So brain infections may happen, or maybe some genetic injuries by birth or by genetics. Then brain injuries, head injuries, strokes, or brain tumors can damage the brain tissues and cause the seizures. Then brain infections, uh, like meningitis or encephalitis, can lead to epilepsy. And other factors like high fever, alcohol, then there are certain medications, certain trigger, stress triggers the seizures in some individuals. So now, what is the diagnosis and treatment, which doctors follow? So we had a conversation with the clinicians, and the doctors over here really helped us to understand the entire diagnosis and treatment, so that we align our research towards, the real time experimentation in coordination with the clinician. So medical history is taken, wherein a detailed history of seizures, other medical condition is done. And then physical examination, the doctor, what they do is they assess the neurological functions and rule out other conditions. Like there might be, see, we all are engineers and we know that system engineering is so very important. Many a times one particular block malfunction affects the other blocks as well. And then while we talk about the entire success of our implementation, the entire system we need to take into picture, rather than considering the individual modules in silos. So there are certain situations wherein this neurological function could be because of other reasons. So that examination the doctor does. This particular assessment is done by the doctor, understanding and whether it is actually a seizure or is it some other conditions which are leading to this particular problem. Okay, so once this is done, the doctor, what they do is they rule out the other condition and they assess for neurological functions, and they perform the ECG. Now this is a test which measures the brain activity to identify the abnormal electrical signals which are present in the brain. And there are various methods to do this. Then there are imaging tests, MRIs and CT scans are provided, which provides the detailed images of the brain. And through this image, of course, what's happening over here is, when a brain image is taken, maybe earlier there were certain unseen part. Of course, still I would say that brain, a lot of research has been happening on brain, but still I must make the statement that we only know 90% of the brain, and still some portion is yet to be revealed. So a lot of research opportunities are there in this, of course. But then when we talk about MRI and CT scan, these images of the brain are taken, and from this brain images, the abnormalities are detected, right? So sometimes the scans will not make the clinician see the abnormalities. So where AI comes into picture is making the clinician see what is not being seen with normal scans, MRI scans and CT scan. And there the role of the technology expert come into picture. So what we do is, we do a lot of AI based imaging on the MRI image, CT image, and the abnormal detection happens, right? Then treatment and options, like, so whether this is medication is sufficient, whether surgery is required, or and of course lifestyle changes are all potential treatments for this epilepsy. So this is the diagnosis. And of course medication, lifestyle changes, just now I mentioned anti-seizure medications, first line treatment happens. Then there are certain lifestyle changes to avoid triggers, getting enough sleep, managing stress. Simple things are also, taken into account, and connecting with others, support groups, who might be feeling same kind of symptoms, who are undergoing same kind of treatment, need same kind of emotional support and practical advice and advocacy. Raising the awareness about the epilepsy can help break down the stigma and promote the understanding. Early detection is always better, because once we are doing it early, lot can be happen rather than going for a surgery. Maybe medication can help or like that. So when we talk about electroencephalography, that is our EEG, which is a non-invasive neurophysiological technique which is used to record the electrical activities in the brain. Now, this signal basically is is like, it signal is generated by synchronized activities of neurons, and there are millions of neurons in the brain. And in the brain, what we do is we measure this through electrodes. How? The electrodes are placed on the scalp and the measurements happen. Now, the section of this, like, there are two various ways. And basic version is 1020 system, 1010 system, and nowadays there are advanced systems also which are available, which are 2030 systems as well. Now, most widely used systems for electrode placements, standardized electrode position, which is anatomical landmarks are there, and that specific 1020 nodes are focused, and then on the scalp that is placed. Now, a more precise system is there which offer greater spatial resolution by placing electrodes at, say, 10% intervals distance on the scalp. Now, suppose there are certain specific issues, then there are customized arrays also. In that specific effective area, specific arrangement of electrodes are done for focused studies and targeting a particular region of interest in the particular brain. So these are the techniques. Now, there are active electrodes when we say how the things are happening. So you can see this is the scalp, and then you have active electrode, and there is a reference electrode. The record electricity the record of the electricity or electrical activities which are present through the scalp, directly they are captured, and they are done, like, there should be a baseline. So the reference electrode acts as a baseline for measuring the electrical activities which are present in the brain. Right now, usually these are placed on the scalp, that, like, non-neural areas. So this is like, let me show you how the typical recording happens. So you can see this is the brain, and then non-invasive, the nodes are available in this particular way, like you can see FZ. So these are the nodes which are available, and you can see that electrodes for reading, these electrodes are placed on the scalp for reading. Then there's a channel selection, amplification, and of course the filtration, A to D conversion, and digital filtering and computer storage happens. So electrode placements happen in this specific pattern. So this is the standard specific pattern. Then when we consider the parameters, which are the parameters we need to consider is gain and bandwidth. There are amplifiers, because this is very the amplitude and frequency of the signal needs to be amplified, because I mean to say, these are very small EEG signals, most of you might have seen, and what we need to do is we need to boost the amplitude of the EEG signal, and we need to select the frequency range. So that's why we require the pre-processing of this particular input. Then high impedance minimizes the signal loss caused by electrode skin resistance. Then noise rejection is also important, because while we are doing, then there could be some noise or artifacts which are coming from the sources which are outside of the brain, but the organs which are present in the human body, maybe nearby the brain and the other activities. So noise reduction is also very, very important. And while we are working on this, what is the sampling rate, then filtration. So we all know the sampling rate. We determine the number of data point sampled per second, ensuring the accurate capture of rapid brain activities. the filtering. Now, as I said, if you want to remove the unwanted frequencies from the signal, and we need to enhance the quality of, so whenever we talk about this signal, it could be alpha, theta, then gamma. These kind of signals are available. And then suppose there is a noise in specific region, the noise removal is important, and we need to use the filter for removing the unwanted noise. So noise reduction strategies, what are the noise reduction strategies? Because the entire success of our implementation lies on data annotation, then pre-processing, the filtration, uh, because you all know garbage in, garbage out. So this is to be done very 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 carefully. And the we need to reduce the electromagnetic interference by using, say, certain conductive materials and grounding techniques. Then there are digital filters which are used to remove the noise and improve the signal quality. Then there might be, as I said, there might be some artifacts, and then the identifying this artifacts and removing this, eliminating this unwanted signal. Say for example, when the ECG is being taken, there are certain eye movements or some certain muscle activities that also gets recorded. Yeah, so that is very important to identify that this is not actually the brain signals, but this are happened, these are the artifacts because of the eye movement or muscle activities nearby. So that is very very important. So handling the artifacts and correction is crucial. As I said, we remove the contaminated data, and then what we do is we replace the artifact with which estimate the underlying signal. So ICA, independent component analysis, is what we also here, because this is a powerful technique which is for separating and removing the artifacts from the EEG signals. So and it worked very well. I'm going to talk about all those models in detail and how it works. So maybe this is the clinical applications. I would like to just quickly brief on that, because more time we would be focusing on the experimentation which we did. So epilepsy diagnosis, then there are certain sleep disorders, then brain injury assessment, cognitive functioning, then cognitive protection processes like attention, memory. So all these kind of applications are there. Then what are the limitations in this particular research? Is data limitation, then individual variability, because what happens is there are a lot of varieties and variations which are available, and it is very difficult for getting all kind of data sets. And that is one data limitations. And developing personalized prediction model is also one challenge, like to cater to the individual differences in seizure patterns. Of course, there's a lot of work which is happening in this particular area. And yeah, one more challenge is ethical consideration, because there are human, there are patients involved, there are approvals, ethical approvals, then data privacy, potential impact on the mental health, because there are so many complications which may arise. So all these are the uh, important factors. Now, the non-invasive neuroimaging techniques were used, and the electrical signals in the brain uh, were, recorded. And I would like to show you, like, as I said, early intervention is always better. Accurate seizure prediction is important, like timely intervention will reduce the severity and duration of seizure and improving patient outcome. So medication management, like patient can proactively adjust their medication regime based on prediction. So this is like a support system to the clinician, wherein a lot of support can be given to the patient, improving the quality of the life. Seizure prediction empowers the individual with epilepsy to make the informed decision about their livings, like what should be done, what should not be done, leading to great sense of control and independence. So this particular work is going, like, impact in this. So most of the work is published. So I'll be talking about the work which is published. This is an ongoing research which we are doing. So most of the work is published. So that part I'm going to discuss, but there are few things which are yet to be published or in pipeline, so maybe I might not cover those part here. So leveraging the open sources repositories was first thing in our mind. We did that. We also understood the perspective of the clinicians, the doctors, then uh, what should be the epoch length. uh, what is epoch? Basically, it's a segment of EEG data, typically a few seconds long. Then there was a challenge how long it should be. Too short is not good, too long is not good. Then what, that also was one challenge. I'll talk about that also later. So analyzing and extracting the information about the brain states and the events is from this particular EEG signal. It's a non-invasive neuroimaging technique. Now, the signal quality and cognitive task and analysis methods used for epoch length selection factor. Now, how do we decide on this epoch length? So what are the factors which will impact? Now, very interesting to understand that what are the noise levels which are present, what are the artifacts, and the signal stability, and what is the influence in selection. This is one of the important parameter. Now, the type and duration of cognitive task being studied can dictate the ideal epoch length. So cognitive task. So it is dependent on several parameters. Then there are certain analysis methods, specific analysis techniques employed, such as time frequency analysis. So time series data is there. So event related potential. So that this all affect the epoch length. So what is the trade-off? As I just said, ki epoch should not be short and should not be long. So for higher temporal resolution, better you capture the rapid brain activity changes. Like, but many lack sufficient data for reliability analysis. Too short is not good, but short epochs can, you know, offer high temporal resolutions, and it will give us a better capture of the rapid activities which is happening inside the brain. But the issue is lack of sufficient data for reliable analysis. And what we can do is we can provide, uh, maybe instead of going for short epoch, go for a long epoch. Provide more data for analysis, but can, you know, um, have issues in sudden changes which rapid happens in the brain activity, and there are potential increase in noise levels, then that issue happens. So it's a trade-off between this two. So that was one practical challenge. And then there are certain practical considerations: computational resources which were available, what are the time constraints of our real-time application which we are working on. And then what we thought of is um, the the specific task complexity, and then based on that, these three parameter we decided. Then optimal epoch length for EEG analysis, which is a very crucial step in ensuring accuracy and reliable results. What we did is we carefully consider these all factors. We also discussed with the doctors. We saw the, we referred to the research which was already done, and we made an informed decision based on that to maximize the effectiveness of this particular study. Then, which are the deep learning models which we explored? As I said in the beginning, I'll be talking about three models. The three models which we'll be talking about is convolutional neural network, that is CNN, and recurrent neural network, right? That is RNN. So most of the basic algorithms we were, trying to experiment. And what we did was, we use these three model LSTM also. That is, most of you are aware of CNN. Let it be a little interactive in between. How anyone working on this kind of model, CNNs, RNNs, and LSTMs, maybe for some other applications, not for seizure detection, but for some other application, maybe you can just text or something. Am I audible? Okay,
Yes,
perfect.
madam.
So I
Yes, madam.
think
Your
as you
voice
are
is very much
muted,
audible.
you are not able to respond. I understand that. No
Madam,
problem.
your voice is very much audible, madam, and everything is going very smooth.
Perfect.
Continue,
Thanks so
madam.
much. Thank you. So, the deep learning techniques for Caesar prediction, what we did was initially we worked on convolutional neural networks. So, CNNs are, they excel at extracting spatial features from the EEG signal. They capture the patterns and the relationship in different brain regions. So, we found that, yeah, they're working well. So, that's the reason when we did the entire deep literature review and the study on that. And then we also considered recurrent neural network as well, because it is a well suited for processing time series data, allowing the model to learn temporal dependence in EEG signal, because we thought this is also very crucial to work on the time series data and understand the learn the temporal dependencies in the brain. So that's the reason we chose recurrent neural network RNNs. And then long short term memory, that is LSTMs, is specialized type of RNN that effectively handles long term dependency in EEG data. So we had to also consider whether there is a long term dependency between the EEG signal data and who, what else we would have thought of rather than LSTM. Then this would have a best choice. Why? Because this gives us long term dependency patterns, and this will definitely, we thought that this will improve the accuracy of the Caesar prediction. So we chose this three models. And yeah, now model architecture and hyperparameter tuning. Now when we talk about the model, the Caesar prediction model, which is designed, which is based on appropriate like deep learning architecture, which considers the characteristics of EEG data and the specific requirements of the task. So this first step was model design. The second step was the hyperparameter optimization. What was that is like number of layers, learning rate, activation function. We need to carefully tune to optimize the entire model performance. So there was a lot of energy and a lot of time which we invested. Then training and validation. The model is trained on a large data set of EEG signal, evaluated on separate validation set to assess its generalization ability. Because usually what happens is, and of course validation to the doctor as well, because as I said, this is a support system to the clinician, to the doctor, to predict the early season. Like what happens is there are certain early symptoms, and sometimes the symptoms are not being understood through the normal image analysis. So with the help of this AI based models, deep learning models, we are able to predict this at an early stage, so that a lot of corrective actions or preventive actions can be taken. So we also did a SWOT analysis, because we should know our own strengths, weaknesses, and opportunities and threats, and what work we are doing. We did a very good SWOT analysis. The strength is like, here is high accuracy rate in predicting with some models which we achieve, timely patient intervention and improved patient outcomes. And then there were certain weaknesses as well. Large high quality data set was needed for training, which leads to overfitting problems also. We faced those overfitting problems. Of course, we later on tried to resolve, and we were successfully able to resolve. I'll be talking about that in detail. And growing interest in wearing technology now. The healthcare industry is booming, and there's a lot of R&D which is happening in this domain. Wearing technology, mobile application, personalized medicines. Of course, there are real-time monitoring also of the patient health. Then what is the threat? Rapidly growing technology. Of course, the ethical concerns are there. Then patient data privacy, security issues are the threat. So that is what I would like to say. Now, what are the key milestones in the model development? The initial research uh, was done on seizure prediction using machine learning way back in 2015, and it was published also. We just found that, oh, the work started in 2015. Then the model training with the help of EEG signal on some data was like, the success for predicting with the sensitivity, getting it for 70%. And then validation phase in say 2019, the model was conducted using a large data set and the improved accuracy and sensitivity. So this was how the research was, progressing in this particular application, seizure detection. So this entire analysis was done, and then real-time testing. The models were tested in real-time scenarios, and false positive rate and were less, so the model was tested in real-time scenarios and demonstrating its capability to predict the seizures with a false positive rate of less than 5%. Now, in 2023, the deployment, I would say that the seizure prediction model was successfully deployed in clinical settings. Earlier, as I said, there's a lot of research which was happening, but the actual deployment, because of the GPUs, NVIDIA processors, and the hardware progress which happened for high speed AI model implementation. So that was done in 2023, and I would say that this provide valuable insights for this deployment was done successfully, and clinic in the clinical settings, which provides valuable insights for patient management and intervention strategies. So this was a starting point, and then entire detail study was done, and there were four objectives of, as I said, first is selecting the optimal length of the epoch, then optimal selection of the channel with different machine learning classifier models, then developing our own kind of, strategy framework, then validating the framework, the model, and compare with the existing state of the art and whether it is performing better. So what is a generalized theme for the deep learning for Caesar prediction? So the methodology, the entire would be stated like this, that the EEG data set, then we also, collected the EEG recordings from the different data set, live data also, with the help of the doctors and the hospital, which I said about the Symbiosis Hospital. Then pre-processing, resampling, and generating the larger data set also was done. Augmentation, data augmentation was used, and we train, then we perform the validation, then test and split. So training and testing, then the data set which was available, we divided that data set into training data set and the testing data set, and then HCLA and BIGRU models which we used. I'm going to talk about this in detail about each model. And then we trained this, tested this, then we predicted the Caesar. I mean to say, we try to classify and identify whether it's a Caesar or normal, and then we perform the performance evaluation. So now, first model which I was talking about is hybrid convolutional bidirectional gated recurrent network, HCBIGDRU. So that is hybrid convolutional bidirectional gated recurrent. How this deep learning model for this particular Caesar prediction would look like. So this is the input, and you can see this is the model, and there are certain, important blocks. So you can see the row max pooling, soft max pooling. This is the output layer when the data transits from the input layer towards the output layer, and then this is ultimately, of course, before the output, you can see there is a soft max. So this is the cross layer attention. There is the importance of weight, and so this is the deep learning structure for Caesar prediction. Now the data set, of course, the data few we just started as a starting point, because most of my students were very comfortable and they were interested to find out what Kaggle is providing. Then also we had referred the international standard databases, CHBM IT database, Boon database. We also combined these three databases and we tried to work on. We also worked on the actual live data samples. We did the augmentations. So we tried to understand the different classes. Of course, initially we limited ourselves to Caesar and non-Caesar. Then we didn't go with much complexity at initial stage, but then later on we definitely worked into minor predictions as well. So we got certain samples, then we did some augmentation, data augmentation, and after the augmentation you can see now when we are performing the parameter, the evaluation parameters. So which are the parameters? There are many parameters which other researchers are working on. Then which are the important parameters? Even though there are many parameters, are we supposed to work on those? Why we are choosing this? So we had those kind of clarity. So precision, sensitivity, recall, F1 score, specificity, accuracy. We thought uh, based on our study and our experimentation that we should consider this parameters, and we considered this five parameter: precision, sensitivity, recall, and F1 score, and specificity and accuracy. Now what we did was k-fold analysis. So here you can see on x-axis the fold numbers are there, on y-axis you have accuracy. Now initially you have, sorry, so initially what you have is k-fold analysis technique which was used for data set. Uh, so 10-fold analysis was used. So you can say 1-fold, 0.85. You can see here as we move ahead at towards say 7, we are getting somewhat 9.98%, so 0.98, and beyond that it is almost maintained. So good enough, like 8, 9, or 10 can be chosen. So we thought that let us go ahead with the 10-fold analysis. Then we did accuracy and loss function comparisons. You can see the epoch and the trained data set and the tested data set. So you can see x-axis the epoch number, then y-axis you have accuracy, and ultimately, so initially it was very low, and as gradually you can see the accuracy is increasing, and ultimately it is being maintained. And the training and testing, there's very minor difference between these two. So you can see the blue detects projects the training, and the orange tells you about the testing, um, testing outcomes. Then we have the losses. What are the losses? Because these are accuracy and loss functions which we consider first for comparison. And we can see that these are the epochs which are there with 200, and here maximum 0 to 1. The losses initially were very high, and then gradually you can see that the losses are dropped down, and as the training happened, and then you can see the losses are very less towards the end once the training has been done during the testing phase. Now the performance evaluation based on the different data sets. I had said data set 1, 2, and 3. uh, the the F1 score, the accuracy, sensitivity, and specificity, and F1 score. So all these four parameters we considered, and the performance analysis was done. And then you can see that the results are better for the data set 3 when we did the augmentation of data set 1 and 2, and then we are successfully reaching towards 98%. So you can see here that the performance is improving. Now we did the evaluation also, the performance evaluation, which was like which methods, which data set, what is the performance already been. There are certain researchers who are you are working. We compared our results with the researchers' results, and then we saw that VGG net. Then we also referred to BNN, wavelet features, SVM, then deep CNN, CAPSnet. There are so many methods, right? Then DBN method, then different data sets also, because of course if you want to compare, you have to compare on the same baseline uh, in terms of data set and in terms of methods. So quadratic time feature plus smooth pseudo Wiener-Villay distribution, which is called as SPWD, VD method and SVM method, then RBF kernel and KNN method. So these all methods, like deep study and analysis was done, what work was done, how much it is been, and how much improvement is been done by this particular new this particular model by using the same line comparison based on the data set. So it has been seen the data, the accuracy is improved, of course, and that's why it motivated us to work on the second model. This was a very basic version of model which we worked on. Then we went for multi-head attention by LSTM. So this particular model, so you can see this is our input EEG signal, and you can see that it passes through different blocks over here: WRC, then STFT, short term Fourier transform, DCT, a discrete cosine transform, PSD, WVD, GSOA. So all these mathematical analysis was done, multi-headed attention, and by LSTM. We pass this to by LSTM, then we pass this to a fully connected layer, and then softmax activation output is available over here. Then while we were using this MHA by LSTM, what were the observations? What were the results? Of course, again here we consider specificity, accuracy, sensitivity in F1 score. But what was the batch size? Because here again it is depended on that. So we took batch size and we did a batch size analysis. The batch size was 8, 16, 32, 64, 128, and then the analysis for all the specificity, accuracy, sensitivity, and F1 score was done, right? So you can see that it is giving much better results when it is 32. Even far when it is 8, you can see that it is giving very lower results. But then if at all you move ahead in terms of increasing it at 128, you can see the results are dropping down. So it is very important that you choose the right batch size. Then after the comparison between this batch size, we also have to compare on the same baseline with that of the first model, right? So what did we do in the first model? We did the comparison based on the 3 data sets which were there, did the augmented data set and the 2 data sets which were available, and then based on accuracy, sensitivity, specificity, F1 score. Again here you can see the performance analysis when was done. So it is giving much better results in terms of this particular data set. So I would like to say that it is also it is working better. Our model is working better and giving us almost 0.99 results. And what about the confusion matrix? So you can see the predicted labels, you can see the normal Caesars and normal, and the two labels, and so these were the results for for the data confusion matrix for data set 1, 2, and the combined data set. So you can see that this combining is improving the performance of the system. Now, when we talk about the results, BCE is the loss function, which is used for what? The binary classification task. So you can see the training and validation accuracies are far better, and the losses you can see that they are very reduced. So this is training and validation accuracy. This is the losses which are there, training loss and validation loss both. Then comparison of this particular model with the other models, like what other researchers have done and what result we are getting. And ultimately we also found that yeah, this particular the comparison was like handcrafted feature extraction and SVM with 2 data sets. No combination was done. People have not combined, but then This is what the augmentation is giving. Uh, so this is the contribution. I would say that this is novelty in the work, bidirectional convolutional model with optimization of attention weights. So two, three data sets, a hospital data set, bond data set, CHB MIT data set was considered, and then the comparison was done, and the results are comparatively much better. So the conventional feature of EEG and multi-headed attention model with bidirectional LSTM and optimization of MHA by LSTM, which we have proposed, is better performing better. So this was about the second model. Now the third model, which is LeanNet model, SWA LeanNet model. Now how and what we did in this particular model. So you can see over here the multi-channel EEG signal. So you can see, so automatic diverse uh, effect of seizure detection model by using SW. As I said, now we need to know the long-term dependencies and relations in the signal. So for that, we use this kind of structure. So this methodology and this model was used, SW LeanNet. So multi-channel EEG signal, we pre-process artifact removal using wavelet transform filtering, and gamma filtering was used. And then um, what was happening is we faced a lot of difficulties here during pre-processing as well as during the FLP coefficient analysis, then signal decomposition also, then feature extraction was done, then what was done is feature reduction, because there were so many features which had come, then deciding on out of these all so many features which one is better to choose, because you cannot choose all. So of course, after the feature reduction, the classification and the classification results with a Caesar, non-Caesar, and other details. So detail analysis. So how, what is the architectural diagram? How this would look like? This is the input. You can see the convolution. Then there are feature map 1, feature map 2, feature map 3. So of course here subsampling happens. Then here you can see convolution is happening, subsampling. So there are multiple stages of it. Feature mapping at first level, second level, third level, fourth level, like this. And then you have fully connected layer, the stages 1, 2, 3, and then you have the output layer. So this is the structure, architecture. So while we are performing this prediction, prediction error also was considered. So how better, like we are doing the prediction, and it means that if you're doing a better prediction, the error will be very very less. So but that's the reason we chose that we should do this analysis as well for the existing algorithms which are available, the work done by other researchers as well as our the PhD scholars who are working with me. So most of them are, two of them already PhD awarded, and two of them are having their defense very soon. So the convergence graph, uh, you can see here. There are different iterations, and these are the convergence values. So the proposed method, the new method which we talked about, um, and PSO, GA, Firefly method, and then we compare all this, and you can see that ultimately the convergence time and the performance is better in case of the proposed one. So the performance evaluation for the proposed and existing algorithms also was done, and you can see that our methods are working much better than the existing methods. So we compared our percentage or score, our score with in terms of precision score, recall, accuracy, in terms of what we were getting and what the other models, LeNet and CNN and LSTM. So all these three models, our results with our own results, we compared, and then we definitely found that this hybrid model is working far better. And so these are the references. Uh, and I would like to conclude. Uh, is there any, how much time do I have? Yeah, so ultimately, I would like to conclude that in this study, we explore deep learning models, including gated recurrent units, bidirectional long LSTM, that is bi-LSTM, then LeNet, I call it SWA LeNet, SWA LeNet, to analyze and process complex data patterns, then GRU and bi-LSTM, being powerful recurrent architectures, effective capture, and what was the main improvement which we would like to emphasize. And as I said, a lot of work is still ongoing, but as this is not, that work is not published, I am not included here. But then what improvement we found is demonstrated is generalization and stability in convolutional architecture, which provides effective um, outcomes. So our experimentation indicates each model has its strength depending on the data type and task requirements. Then GRUs and BiLSTM excel in sequential data processing. So whenever there is a sequential data processing required, SWLENet enhances the feature extraction and robustness in convolutional setting. So the choice of the model should be guided by dataset characteristics and computational efficiency. The future work which we are doing on is hybrid models and optimization techniques to perform the enhancement across the diverse domains. So this is related to the three models which we worked. I would request anyone who is interested, as I said that I'm working as an head industry connected symbiosis, and I work in model-based development as systems engineering, wherein we do not consider individual system output, or it's not important, because many a times we work on in silos. In one, we are concerned with one particular system, but how that particular model in the system is affecting the other systems, and entire performance of the system depends upon their integration, system integration. So that is what is my interest. So yeah, if anyone is interested to connect and work with me in this particular domain, along with, I have 8 PhD scholars who are working with me, then I have 2 MTech scholars who are working, and then there are 6 BTech scholars. So if anyone would like to is interested to know more about what work we are doing, please get connected, scan this, and we'll be connected on LinkedIn. And of course, you can send me a email. Uh, any uh, any questions? So that's all from my side. Let me stop sharing.
Thank you so much, madam. Dear participants, if you have any queries, feel free ask the query.
Yeah, being a very last session towards the dinner time, I totally understand. Uh, yeah,
And
I will just scan.
190 plus participants are present, madam, active
Wonderful,
right now.
wonderful. Let me share my, many of them are asking for the scanner. So let me share my screen for the scanner. Is it visible? Is the scanner visible?
No, madam, no.
Oh,
Madam,
oh,
once you share your slide, madam, once
once
you
again,
share your slide.
yeah. Let me share the screen. Let me know if you're able to see. Is my screen visible?
Yes, madam. It's okay,
The
madam.
screen is visible. Let me go to the
Yes,
scan.
madam. Yes, madam. Your
Yeah,
screen is visible, madam.
visible, na? Thank you so
Yes,
much.
madam.
Yeah. So this is the scanner. Most of you, whoever would like to, know more about the work and would like to collaborate uh, and have any support, definitely I would be more than happy to support. Last month I was in Tokyo, where we had a lot of collaboration activities related to AI, artificial intelligence in biopharma application. So this is the domain which is very close to my heart, applying AI in several
Good evening, ma'am.
applications. Yeah.
I'm
Good evening.
Shailesh.
Yes.
I'm Shailesh in Jabalpur. Madam, whatever you told about your research work, I would like to know whether your CNN model are 1D or 2D CNN model.
So these are 2D CNN models. Yeah, because then when we are working with the signals, um, this kind of signals, it is 2D is always better.
Uh, accurate signal. And your signal, your accuracy results are better than 1D work, 1D CNN model.
Yes, yes, it's better than. So we also initially worked. My undergraduate students were working on the one dimensional, but then we also worked on 2D, and we found that 2D are far better than the 1D.
Recently, ma'am, I have published one work in the journal.
Mm-hmm.
Actually, that is related to heart attack detection. That is in telemedicine application.
Oh, great. Nice to know that. Yeah.
Yeah. And what I have done, I have done signal processing at the input side,
Mm-hmm.
convert 1D ECG signal into 2D image,
Mm-hmm.
and by IoT network, it will be the model is deployed on cloud,
Mm-hmm.
and I will send signal there and check the attack classification.
Okay. So which
ECG intake.
classifier? Which classifier you used?
CNN, that is 2D CNN. That is
2DC.
a, yeah,
Okay, okay. So then how much results improvement you
um,
have got?
results I have got 98% accuracy, but
Mm-hmm.
I have not validated that model on a real data,
Validation is very crucial.
a
This
real time data validation.
real-time data validation involving taking the clinician, the doctors into the loop is also
Yeah,
very much needed when we talk about healthcare applications, because ultimately this is not going to replace the doctors, but they're going to help the
right.
doctors to see maybe what is not being seen by them. I always make a statement that we are making the clinicians see the unseen
Exactly,
data,
exactly.
like in maybe a room filled of dark, without light, they may not be able to see, but we are providing that light for them to see. That is what I always put this statement in this way. Wonderful, nice to hear that. Yeah.
Okay, thank you, ma'am. Thank you.
Good evening, madam.
Good evening.
I'm Dr. Sashitla from Hindustan College. I'm more of this management staff. So
Mm-hmm.
probably all of you here are into technical. But I would like to I would like to ask a question related to now. You speak so much of bringing in light onto what the doctors can see. But I
Mm-hmm.
just want to know the application part of it, like how much of all these models you have found are actually being utilized by the doctors as of now,
Yeah.
because
So
that is what
yeah.
we teach. So that
Yes,
is,
yes. Yeah.
I guess.
Uh,
Thank you, ma'am.
so, yeah, thank you. Very nice question. So, I really appreciate it because See, a lot of research, as I said, my beginning statement was a lot of research is happening, but then most of the research is remaining in the research papers. Few reach the patents, but then what is the journey ahead? Very less technology transfers and very less actual implementations happen and actual useful to the society. Research work is should be aligned. That's what I made the opening statement. So and we are really blessed to have the hospital as well, which is like, we are equipped with that kind of infrastructure. We have the hardware systems, and we have that ethical processes set, which enables us to test whatever research we are doing into the live structure. Um and that's the reason we also tried with some real-time data, and we validated it with the help of the doctors, and the results are amazingly good. The way we predict, because while we were doing the analysis, we did a lot of experimentation with huge data set. But then certain situations, um, initially we didn't get the data set. We faced a lot of challenges, but of course we overcome all those challenges, because it was a long journey. But yeah, we implemented and tested the hybrid model which I said about, and it is at par, it is giving good results. Yeah, and it is helping. Then the doctors were also amazed. Okay, so this was not seen and this was not known to us that this could lead to epilepsy. So maybe we can always take a preventive measure in, controlling the situation, uh, rather than, getting it worsen. So this definitely helped
Okay, ma'am.
prognosis, yeah, diagnosis.
Just one more question in addition to this. So, how long do you actually think will it take for all the doctors to practice this or to take
Sorry.
this into consideration?
uh,
How long will it take for all the hospitals or doctors to consider this part of AI as a part of their diagnosis itself,
Yeah, yeah.
especially in
So
India?
all, yeah, 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 absolutely. So again, I would say this is a wonderful question, because most of them are talking about AI into every domain. We are talking about AI in healthcare. Now here there are two entities to it, three entities I would say. One is the engineering side, technology side, the other is the medical side, and the third is the patient, right? The
Yes,
synchronization
ma'am.
between these three entities, and uh, the biggest challenge is getting the data. The biggest challenge is working on that particular data, because there are certain ethical issues also which arises, and which we are not able to sort it out very easily. But yeah, when we talk about maybe most of the doctors are now, I would make a statement that most of the doctors have now realized that we should not work in silos. We have to collaborate with the technologist, and we also are making a wave, saying that it's not only working into technology silo, but we have to do a handshaking with the medicos as well. And not a competition but a collaboration will take this field very big, uh, in a big way. Though there will be initial challenges, ethical issues are there, security issues are there, but then policies and reforms can find a solution for that. But then yes, doctors are realizing, even the technocrats are realizing that we should work in a handshake mode, in a collaborative mode, and move ahead. So I think very soon, most of the doctors, even now as well, I have seen most of the doctors becoming AI literate, and then AI savvy, tech savvy, and they're working and using those kind of things. Yeah, it will take time, uh, but it's happening.
Okay. Thank you, ma'am.
Thank you so much. Thank you. It was a nice question. So I hope you have scanned this scanner, which will give, you will connect to LinkedIn. So you have to go to your LinkedIn, and from that you have to connect. I hope you're able to connect. I would really appreciate, because this is a very last session, being this odd timings, dinner timings, still you attended. Thank you so much. And I can see 192 members.
Hello.
Yeah.
Good evening, ma'am.
Yeah. Good evening.
Ma'am, I am Pinkal Jain from Gyananga College of Technology, Jabalpur.
Hello.
Ma'am,
Yes, yes.
hello. Ma'am, am
Yes,
I
yes.
audible?
Yes, yes, you are audible.
Ma'am, actually, I am having a query. Ma'am,
Uh-huh.
how we can perform the real-time validation for a healthcare prediction model?
So when we are performing the, of course, there are stages to it. Uh, so once your background work is ready in offline mode, for real time, of course, you need to attach yourself, collaborate with some hospital which is nearby. You're working in which particular domain? Are you working in into any healthcare domain?
Yes, ma'am.
Okay.
Heart disease prediction.
So get in connect with the heart specialist, heart surgeon, or hospital which will provide you with data. First, understand their pain points. You need to go meet the doctor, understand what are their pain points, and try to discuss what work you are planning to do. Does it make sense? Is it relevant? Will it be useful for the practitioners, the medicos? If we perform, like, that's what I said, we should not work in silos. Neither we nor they should work in silos, right? So we should approach and talk about these, and then align our experimentations in line with the expectations, and uh, set the outcomes which you are expecting from the experimentations. And then ultimately, when you are done with all these experimentations, then in keeping the doctor into the loop, then you can test it on the patients with, of course, with the ethical approvals, considering the um, approvals from the patients, and then try it as an experimental basis. And this can help you for real time, and then you can deploy it. Once you, of course, there are so many medical standards and so many things, complexity is huge, but this could be the first step, second step, I would say, and there are many other things which will follow. Yeah.
Thank you, ma'am. I am having one more query.
Yes, yes.
Ma'am, can we call a model perfect only on the basis of accuracy?
No, not at all. So there are many other parameters one needs to consider, and when we are working on real time data, it is very very important, because see, everyone, at least when you refer the research papers, it's all the game of numbers, in terms of
Yes, ma'am.
the model is giving 98 accuracy means it is better, 99 accuracy means it's better. Who knows, maybe overfitting is happening, who knows
Yes,
what
ma'am.
actually problems are there. So we should know that, we should analyze it very critically. Okay, I'm getting the result. Okay, once the paper is published and all, I understand. But then when actually you're working for a real time application, because when we worked for a Philips HIC Healthcare and Innovation Center, we did a prediction model for the C-arm machine. There was an operation theater, and in that operation theater there's an C-arm machine, and an X-ray analysis which happens, and the doctors are able to see and do the analysis on the basis of the image which is being seen on the screen, X-ray image. And a lot of the parameters were hidden, and they were not able to see the detail uh, details of that X-ray image. So what we did was, we did the image enhancement for that. Then that was one part, and then we did the predictive analysis that suddenly the machine fails. Suppose the surgery is going on, the machine is very huge, and the patient is lying there, and the doctor, maybe two surgeons are there, then two assistant doctors and two three nurse, and then in this structure the operation is happening. You just imagine the surgery is in progress and the surgery is happening, and suddenly the C-arm machine fails, and it's a huge loss to the human, because the surgery is happening and the machine has failed. How about if we get a prediction that after this X amount of time the machine may fail, that we take some preventive measures. So we worked on this kind of project, and we did the predictive analysis, and we predicted that after X amount of time the machine is going to fail. And this prevented that before the surgery, if we know that this particular problem is going to come, then the corrective actions were also recommended based on the data logs. Those data logs which were present, and we took the data logs and we applied artificial intelligence deep learning models, and we analyzed the data logs, and then we predicted that there would be a machine failure in X amount of time, and then the corrective actions and measures were taken.
So,
So
ma'am,
yeah,
apart from the accuracy, we have to consider more parameters also.
yes,
So,
more parameters.
actually, ma'am, generally we consider four parameters, that is accuracy, precision, recall, and Abban score. So
Yes.
these parameters are sufficient to measure the performance, or apart from these parameter, few more parameters are required.
So I think we did lot of R&D in this, and
Yes, ma'am.
in that we found that these four parameters are, good enough. But then again, I would not say that this is a fixed thumb rule. I would say that it depends on what kind of data set you're working on, which kind of application you are working on. But these 4 to 5 evaluation parameters are crucial and important.
Actually, ma'am, I have seen lots of papers in
Mm-hmm.
which authors only consider one or two parameters, and
Mm-hmm.
even they also consider the unbalanced data set. So their
Hmm.
accuracy will become 98, 99, and
Yes, that's what
99
I'm
point
saying.
something.
Yeah,
So
that's why I said number game, na. It is
yes,
just
ma'am.
application. I mean to say, I'm not saying, I'm not doubting anything, but what I
Yes, ma'am.
want to say is,
यार
we
बंद
need
करो,
to.
बहुत हो गया ये। बहुत चकर चकर कर ली है इनने, 2 घंटे से पका रही हैं। वही वीडियो ऑन करवाएंगे बंद।
So what I mean to say is a holistic systems thinking is required when we talk about the implementation in real time. So one or two parameters or only accuracy is not sufficient. That is for sure. Yeah. Thank you
Okay,
so
ma'am.
much.
Thank you so much.
Any other?
Thank you so
Any
much,
other?
ma'am.
Thank
Thanks a
you,
lot,
Manoj.
ma'am.
Yeah, thank you. Let me stop sharing my screen. Thank you, organizers, for providing me opportunity, and thank you, everyone, being so much odd timing you have joined. Thank you so much.
Ma'am, once you switch on your camera, madam. I request to all participants kindly switch on your camera for the photo capturing. I request to all participants kindly switch on your camera for the photo capturing session 2. Thank you so much. Thank you very much, Dr. Mrinal madam, for delivering such a very wonderful, knowledgeable session and satisfying the queries of our participants and the very interaction session, and the people are asking very realistic question with you, and obviously they will getting the some knowledge, and the doors are open for the new research as well as the feature selection as the Dr. Pinkal is asked, and your real-time example research experience and the industry and contact your inputs added the very valuable for the subtle FDP. The clarity with which you explained, madam, during the session, and the complex concept you are explained in a very nice way, in the very easiest way, how to maintain the data and how step by step process to analyze the data. We also connected academic learning as well as the with industrial applications and the real-time example you very nicely explained, madam. So on a behalf of AICT Atal Academy and the Gyan Ganga College of Technology, Jabalpur, and all the participants, I extend our sincere gratitude and thanks to you, madam, for delivering the wonderful session. Thank you so much, madam.
Thank you so much for providing me this opportunity. I am grateful to the organizers and the phone calls, the follow-ups, the emails. Very promptly and smoothly, everything is executed, and I was very happy to see the huge numbers. Even though this is a very late night session, it's almost 9 p.m. But yeah, wonderful. Thank you, and I would like to collaborate. If anyone is interested, we can join hands for joint research. Thank you so much.
Thank you, madam. Now, dear participants, we are ending this meeting. The feedback link is the attendance link as well as the feedback link is shared in the group. Without fail, you will submit your feedback. It will be uploaded to Atal portals to getting the 80% attendance. The 80% attendance is required for the certification as well as the assessment. Thank you so much. Now we are ending this meeting. Thank you so much.